Good evening, wherever in the world you happen to be, and welcome to today's webinar, which takes the business case for hybrid and electric technology in Asia as its theme. The webinar will be 55 minutes in length and is part of Riviera's Maritime Hybrid Electric and Fuel Cells Webinar Week. Today's webinar is brought to you in proud association with our premier partner, Navtech, and is generously sponsored by ABB and ABS. Now, ladies and gentlemen, before we get underway, I'd like to share with you some key information that will support you in getting the most out of today's proceedings. Please be assured we will send you the recording. Please send your questions through at any time because we do Q&A throughout the webinar. And any questions that we don't get to, we do come back to you in writing within a week of transmission. So there's every reason to get involved and send through your questions. Please stay tuned into the end so you don't miss out. I guarantee that over the next 55 minutes, we will be sharing powerful, original, and exclusive insights of real benefit to you and your operations. So do stay tuned. And at the end of the webinar, please complete the exit survey and we'll send you the presentations and recordings. Well, ladies and gents, let me introduce your hosts, Riviera. Riviera Maritime Media is a maritime and offshore information specialist active in 4 areas: news, events, jobs, and data. To learn more, please visit the dedicated website www.rivieramm.com. Well, ladies and gents, this is me, Edwin Lampert. I'm head of content at Riviera Maritime Media, and I'll be moderating proceedings today. So speaking of today, this is what's on the agenda: understanding the key benefits of hybrid and electric systems, breaking down the costs involved for owners and operators, all electric vessels, the challenges and advantages, new build versus retrofits, factors to consider when making investment decisions, life cycle management of hybrid and electric vessels, owner and operator insights, key business drivers behind investments into hybrid and electric systems, and the green agenda, incentive initiatives in Asia. This, ladies and gentlemen, is the running order, or in other words, how it's going to go. Presentations will be run consecutively and followed by open discussion. As you know, please submit your questions at any time because we do Q&A throughout the webinar. And at the webinar's close, we will share key takeaways and conclusions and also preview what's next. Well, ladies and gents, what's next for us is meeting our panelists, and there's a fantastic panel in place. We have Chi Wei Lui. Chi Wei is Senior Principal Engineer with ABS. Also joining Chi Wei today is Ricky Chan, based out of Helsinki, and he's R&D Manager with ABB Marine and Ports. And completing our lineup today, I'm delighted to welcome Ferhat Akuna. Ferhat is, of course, General Manager with Navtech Naval Technologies. During the next 55 minutes or so, we'll find time for a poll or two. And as you know, ladies and gentlemen, do keep those questions going via the webinar chat, and we will get to as many of them as we possibly can. Well, more than enough from me. It's time to hear from the people we've all dialed in to hear from. And first up, I'm delighted, it's Ricky. Ricky, so as and when you're ready, good sir, the floor, as they say, is yours.
All right, thank you. Good afternoon and good morning, as well as good evening, wherever you may be. Thank you for taking the time to attend the seminar today and the presentation from ABB titled Decarbonizing the Short Distance Shipping Sector, where today we will discuss some of our product and solution offerings, as well as some opportunities or challenges where we see and how we can support our customers to electrify their vessels. At ABB, we believe that the next generation of vessels will be electric, digital, and connected. The future of marine power systems are electric, where we believe ships, especially those operating in the short distance sector, are best operated by batteries or fuel cells or a combination of them. With digitalization, we see an increasingly number and variants of sensing technologies as well as cameras that will provide information to our captain as well as the operators, where they can make the ships more efficient to operate as well as more precise to handle. And we also believe that gradually ships will become more automated and we will see autonomous commercial operations to some scale in the near future. With connectivity, we mean human in the loop here. While more operational decisions and optimizations will be made and will be done by powerful computers through analytics or artificial intelligence algorithms, human will remain in the center of the operation, at least to oversee or even to take control and give commands in certain conditions when needed. Connectivity will also enable new remote services where shoreside centers, operation centers, as we can see in the picture here, will be the command and monitoring center to supervise activities on board across the whole fleet. What does it mean exactly? So today, for the focus, we will be discussing mostly about electrification and electric powertrain. One of the key drivers for electrification in the marine industries is reducing emissions. An electric ship today can be operated without any emissions, running purely on batteries that can be charged from shore power connection. If there is a higher energy demand beyond the ferry, as we take an example here, the vessels can also be powered by multiple energy sources such as fuel cells in a combination with battery. We believe that when electricity and hydrogen production through electrolysis can be obtained from renewable energy sources such as wind or solar, it will make the vessel operation practically emission-free in the whole entire value chain. Additionally, as we can also see in the illustration here, an electric vessel is simpler compared to its diesel counterpart. It is more efficient as well as more flexible in terms of equipment layout and arrangements. Electric ships don't need for instance, the lubrication oil or fuel tanks in the same magnitude as compared to the diesel powered ships. And many of the complicated systems can be totally removed, and the vessel designs will be more optimized for the purpose that they are serving. And this is also valid for the entire life cycle of the vessel, where maintenance will be reduced and wear and tear will be reduced as well. On the journey towards zero emission shipping or carbon-free shipping, in other words, we believe that there are steps or milestones as the technology matures, and this involves on the fuel side as well as the energy conversion technology. Supporting infrastructure also needs to be built and needs to be in place and supported by regulations as well as operational readiness. We collectively as an ecosystem here need to look beyond the technology on board of the ships itself to realize this vision. Currently, there are already over 400 vessels equipped with batteries or energy storage, either in a fully electric configuration or hybrid with engines. We see that this technology or this design configuration is becoming the near-term trend, especially in the short-distance shipping sector, where the enabling technology is mature. The energy storage technology is mature and supported by shore charging system. It is entirely feasible to have zero emission operation already today. As the energy demand grows with the vessel size or with the operational profile, we believe that hydrogen fuel cells in combination with energy storage for peak shaving as the leading alternative. And for that, we have been actively participating in fuel cell demonstrator projects, such as shown here, the Maranda and Flagships projects, both of which are funded by the European Union through the Horizon 2020 program. In the long term, with the maturing technology in liquid hydrogen storage and bunkering systems, sufficient energy can then be stored on board of vessels for zero emission port of call, which is attractive for the cruise industries, as well as for purely hydrogen powered ocean going ships in the future. And for this, ABB have been actively working with Ballard to develop the megawatt scale fuel cell systems. In addition to fuel cells and battery technology, as we have discussed previously, we also offer a complete system offering in order to fully support our customers in meeting the environmental goals. Starting from the platform based on modern DC distribution system, we have the onboard DC grid, which has been designed to be fully modular to increase flexibility and to also fit various vessel types. With onboard microgrid, it is an attractive solution for smaller vessels where we believe that footprint and weight are a premium. However, we also don't want to sacrifice performance as well as the ability to utilize battery or fuel cells as the energy source. Lastly, we are also actively discussing with regulation bodies, partners, suppliers related to charging systems, and we will continue and offer our support for vessel owners in selecting the suitable shore charging solutions, be it ABB's robot-based solutions or integration with third-party to simplify their selections and to ensure reliability of the systems. Now, I would like to also take you through one case study of one project where ABB is involved in the flagships project. In this EU-funded project through the Horizon 2020 program, we are one of the key partners in the development of a hydrogen-powered river pusher, which is owned by CFT, a part of the Sogestran Group. In this project, we are providing the power and propulsion systems as well as the power management systems. The fuel cells utilized in this project are Ballard's 2x200 kilowatt module, and it is in hybrid combination with energy storage for peak shaving purpose. Although it can be seen from this illustration that diesel generators are equipped on board, the goal is to operate the vessel purely on hydrogen while it is being operated at its home port in Port of Lyon, as well as along the Rhone River, where hydrogen is available, as well as the hydrogen infrastructure is being built. The generators are only used when and if the vessels are being operated in areas where hydrogen is not available and refilling infrastructure is difficult to reach. When it enters service in 2021, with the hydrogen produced from wind and solar energy through electrolysis, the vessel operation with such green hydrogen is expected to reduce approximately 80 tons of CO2 emissions per year, which is significant considering the urban area where the vessel will operate. And with that, I thank you for your attention, and I hand it back to Edwin.
Thank you very much indeed, Ricky. Great presentation. Next up is Chi Wei. So Chi Wei, as and when you're ready, sir, the floor is yours.
Thank you very much, Edwin, and good day to all. We are very glad to have the opportunity to speak with you all here today. So today I will cover the following topics: hybrid electric systems and also all electric vessels. Hybrid electric power systems combine conventional generators or internal combustion engines with energy storage systems and potentially with alternative power sources such as fuel cells, solar, and wind. The recent drive towards decarbonization and a sustainable future is spurring the rapid development of hybrid electric power systems. The benefits of hybrid power applications are convincing. They can optimize and minimize the use of onboard generators. This aids in reducing fuel consumption, therefore leading to the reduction of emissions. The use of energy storage systems and advanced power management systems increases the system's overall capabilities and provides inherent redundancy. An optimized system shifts the reliance from internal combustion engines to energy storage systems and the alternative sources. This lowers the engine's running hours and fuel consumption. Additionally, electrical equipment tend to be more reliable and require lesser maintenance compared to mechanical equipment. As such, an added benefit will be lower maintenance costs. I'd like to discuss the two projects that you see on your screen now, the Seacall Maya and the Harvey Energy. The Seacall Maya was the first vessel retrofitted with lithium batteries for operation in the Gulf of Mexico. The batteries assist in peak shaving and load leveling, thus enabling the optimal use of the existing generators. Fuel consumption has reduced by as much as 20%. Similarly, the Harvey Energy has installed a modular battery system, in addition to its dual fuel engines. The installed battery power allows the vessel to sail in and out of harbor purely on electric power, thus reducing noise and pollution levels. They also provide redundancy during critical DP operations. Moving on from hybrid vessels, we'll talk about all or full electric vessels. Firstly, we need to differentiate the market into two segments, namely the short sea or domestic vessels and deep sea vessels. The operating profiles for short sea vessels are a good fit for the use of electric vessels. For example, ferries can do a quick charge while docking, and for tugboats, it is more efficient to use batteries during its low load idling period. Utilizing all electric vessels for the short sea segment is really a low-hanging fruit. Firstly, it is technically feasible. Secondly, being close to shore, it is close to its support network. Reduction in maritime emissions in port cities in Asia, such as Singapore and Hong Kong, will have an immediate positive and visible effect on air quality. This will in turn improve public opinion and increase the political will in the drive for sustainability. However, there are some challenges. Currently, there is a lack of charging infrastructure, not just in Asia, but globally, and there are no standards governing them. Charging time for batteries will also have an impact on the commercial viability for such vessels. For the deep sea segment, the advantages are clear. It will bring about zero emissions, and all electric vessels will be more efficient as compared to diesel or diesel electric propulsion. However, due to the low energy density of batteries compared to fossil fuels, it is still not feasible for large commercial vessels to go fully electric. Based on current technology, its range will be limited. If and when we are able to overcome this technological barrier, the regulations in its current form will also be a challenge. A new goal-based approach will be needed for all electric vessels. So the key takeaways from my presentation today will be the technology involved is maturing. There are clear benefits for hybrid and oil electric vessels. And in fact, the adoption in the market is gathering pace. And there is a strong potential for full electric vessels in the short sea segment in Asia. So thank you very much for your time today, and back to you, Edwin.
Thank you very much indeed. A fantastic presentation, which has stimulated a number of questions. Ladies and gentlemen, do keep your questions coming. More immediately, I'm delighted that Ferhat is up next. So Ferhat, as and when you're ready, sir, the floor is yours.
Thank you, Edwin. Welcome, all the attendees. Thank you to listening to us. Navtech, my company, I'm general manager of Navtech engineering company. We are last 6 years focused on environmental projects on marine business. So during these studies, we have developed ZTUG, a tugboat, a harbor tugboat, having no emissions at all, chargeable technologies. So we call her ZTUG, zero emission electric tugboat. We have designed this boat and built, and now in Istanbul, Turkey, she is running for a tugboat operating company. Name is Gisaş. This project is very important for us because this is, as far as I know, that the biggest powered harbor tugboat running fully electrical, approximately 2,000 kilowatts of propulsion engines, two electric motors on board of the vessels to propel the vessel. She is totally zero emission. It means that regarding to our calculations, every year, approximately 200 tons CO2 and 9 tons NOx emissions will be omitted while operating this one regarding to a diesel, let's say, equal harbor tugboat. Let's talk about a bit how she is, how to say, working. She has two sets of. First of all, I would like to say that this is a conventional propulsion. I mean, it means shaft, propeller, and so on. This is not ASD or Z drive or something else. Anyway, she could be, but this is regarding to the client's request. Propulsion system consists of two sets of double-wired induction electric motors, not PM, by the way. The power rate is 925 kilowatt each. And we have Corvus brand batteries, Corvus by Corvus Energy, 1,450 kilowatt hours battery on board in two redundant battery rooms. The system is fully redundant as she is full electric one. There is no diesel engine at all, so all the system is redundant. And these battery rooms are located one at fore and one at aft, and the cooling system is air cooling system, and we're providing with a special chiller system with very low consumption of electric. And she being designed and built according to the Turkish Lloyd's rules, but totally suit to IAX member classification society's rules, because we have checked all the main classification society's rules regarding to the battery powered ships, and it is almost for this particular example we can just apply to another IAX member classification society to build a new one. And first of all, I would like to say that for full electric rechargeable technology, full electric ships, it is very important to study on the operational characteristics of the planned vessel. So it should be custom made because the energy is battery power is limited for today's technology. So you have to check the operational requirements and you have to design customly for the need. For this particular one, we have studied 5 similar tugboats, harbor tugboats, for 5 years statistics, and we have created an operational profile of it. And now the battery powered new one, ZTAC, fulfilling these characteristics. During these studies, we need to check the operational characteristics. As I said, that these are in main items: how often the tugs operate, how long an operation takes, distances to be sailed during the operations, which is very important to determine the battery capacity, and the power requirements for the different operations. This is again very important because, let's say, when we're talking about 30 tons bollard pull, it doesn't mean she needs that 2,000 kilowatts of power all the time. She needs that for a while, and these time and power graphs shows us the energy profile, and then accordingly we continue. As I said, that Navtech is an engineering company, but this kind of innovative projects, we also have a capability to build them as we built ZTAC 30. We call ZTAC 30 because 30 tons of bollard pull capacity. You can see over here the size of it. Also, there is another challenge. As she is a battery-powered full electric tugboat, we made a smaller one than the diesel ones. And smaller and more powerful and more maneuverability capability and so on. And also, let me, okay. Anyway, I would like to also tell about stamps. there is a software on board of the vessel, Smart Tug Energy Management System. This is also very important because this is a part of these kind of Z-Tugs from now on. She's controlling, this software is controlling everything, and also the connection to the other Z-Tugs and the main ship to be served, and headquarter and operation center and so on, and checking all the information about sea state, weather condition, and the charging station occupation and so on, and regardingly commenting and regardingly advising to the captain and the headquarters and the operation centers. This is very unique software, and for fleet, of course, not for only one ship, but this software is providing the connection, necessary connection. Z technologies, we call Z technologies, zero emission electric technologies, is not limited with this ZTAC 30. Our company is continuing to study on developing Z technologies for ferry, landing crafts, coastal fishery boats, leisure boats, tugboats, the other type of tugboats. And also even we have another R&D project on ports to modify or to build up zero emission or lower emission ports, environmental port facilities. So you can see in the table that what we are doing nowadays, we are continuing ZTAC series. I mean, zero emission harbor tugboats, 30 tons are already the first one delivered, and the others are continuing on building. ZTAC 5, ZTAC 20, ZTAC 30, and so on. These numbers are showing again the bollard pull capacity, and each one of them is a unique project because we have to check the operational characteristics and so on. And also we are continuing with some other type of ships with this Z technology, a small tanker for garbage and sewage collecting tanker, which is very interesting because also a waste process unit for domestic waters and serve to the yachts and leisure vessels, and another remote autonomous 5 tugboat will be again totally chargeable power on board. And another R&D project, as I said before, Z-Port, which is shown simply zero emission port facility. We have studied a lot on it, and you can see the figures over here. This is when you're using solar power, wind power, according to the possibilities, biomass plant. And then after you can see that this is very efficient, economically efficient, and also very less emission, even up to no emission. Of course, this is a bit future aim, but it is shown like this. I mean, you're using Z-Tags on board on this port, let's say, and all the cranes, forklifts, and these kind of vehicles will be battery powered, electric ones, and there will be several charging stations, charging points, and so on, and wind turbines, solar plant, and of course a storage facility. All these things being studied up to now, and we have seen a quite successful result through it. You can see over here, this is a small to medium-sized port to modificate electric port, let's say, or lower emission electric port at this stage. Approximately less than 1 year, 7 to 10 months, you can complete this conversion, and CO2 emission reduction will be approximately 63% regarding to the original one. No noise during the operations, and investment cost we have calculated 6.5 million euros, and operational cost reduction is amazing, and then return of investment seems that 5.5 years for such a conversion, a port from conventional one to electric port. This is very important study. We have done this through a real example, and we have found these figures, but we will continue with some real ports to get some more successful results. Well, at the end, I would like to say that the future is electric, and all shipping business will turn their faces to electric-driven systems, even the ports, ships, and everything. So we have to be a part of solution, not to be a part of pollution. So we have to stop pollution. Then Navtech is always ready to study, to make so many studies for your port, your fleet, and so on. And we are ready. Thank you, and back to you, Edwin.
Thank you very much indeed, Ferhat. Great presentation, which has stimulated very many questions. Let us take a survey or two before we actually get to the question. So, ladies and gentlemen, on your screens in front of you is a question. It reads, the industry will see widespread adoption of hybrid electric power systems in the medium term. We're talking 5 years from now. Do you agree or disagree? A binary question. You'll all have a view on that. Please do keep the votes coming. We will report the findings in an article after the webinar. You'll all have a view on this one. Don't be shy. Do you agree or disagree with the contention in the statement? The industry will see widespread adoption of hybrid electric power systems in the medium term. What I can tell you at this interim stage, a clear majority, about 61% actually, are favouring the agree option. So good news for our panel, I'm sure. Let us do another poll quickly, and then we will come to those all-important questions, ladies and gentlemen. So here is the next question. What is the main factor stopping you from embarking on hybrid electric power systems, from embarking or selecting? Is it capital expenditure cost? Is it doubts around the efficacy of this technology? Is it lack of crew training, or is it safety concerns? I can tell you, ladies and gentlemen, all 4 categories are registering votes. Do keep those votes coming in. As you know, we do report the full findings of all the surveys that we take in an article after the webinar. Let's just give it another 10, 12 seconds, and then I'll give you an indication of the standings of the 4 categories. Just to remind you, capital expenditure costs, doubts on the efficacy of this technology, lack of crew training, and safety concerns are your options. Just 5 more seconds. Let me tell you, ladies and gentlemen, that in 4th place as we speak, and the votes are still coming in, is lack of crew training. In 3rd place, it's safety concerns. In 2nd place, it is doubts on efficacy of this technology, and by quite some margin, the biggest factor, according to you, ladies and gentlemen, that is stopping you or hindering you from fully committing to hybrid electric power systems is the capital expenditure cost. We'll give you a breakdown of the percentages in that article after the webinar. Right, ladies and gentlemen, let me make good on my promise and turn our attention to those all-important questions. Ferhat, let us come to you. I appreciate you've just spoken, but we'll keep going if you don't mind. The bollard pull test that you referred to, how long does it take, and how long can she pull 32 tons?
Yeah, this is a very good question because in the presentation we couldn't put so much details. A bullet pull test being done according to the classification society rules. Exactly, I cannot remember right now how many minutes it takes with 32 tons. I remember something 10 or 15 minutes without interruption, but it was according to the class rules and done with 32 tons. In fact, we have designed this one to 30 tons only, but 32 a bit more, something 32.5 tons. At least 10 minutes, I remember, but I can check and I answer this question firmly in written because I have to check the classification society, how to say, certificate and so on.
That's very fair. No problem at all. One more for you, Ferhat, and then I'm going to broaden out to your colleagues. Could you amplify on the charging infrastructure needed and the additional capex needed to install the charging stations, please?
Yeah, this is also a very important point. The charging infrastructure, in fact, you can divide it into two main topics. The first one is a charging unit. You should arrange your port facility or wherever you berth the tugboat. This is a small, how to say, I can say that it is totally depending on how long you want to take the charging process. Let's say in ZTAC 30, this is 1 hour for full charge. I mean, when ZTAC 30 is totally empty and come back to the port facility, she is recharging herself in 1 hour together with a quick charge station, which again we have designed and built, which is approximately, I can give a figure even, 300,000 euros or something like that, the cost of this charging station for quick charging for this kind of a tugboat. But this technology also provides some other meanings of charging. Let's say our vessel is charging through this QCS, very quick charging, and also on board of a vessel we put a very small, as far as I remember, 100 kilowatts even, diesel generator for emergency cases, not exactly emergency cases, but 5-5 operations she is supporting, and take me home device, something like this. You can charge through this generator, and also when you connect shore connection, you can go through shore connection. Of course, these last two options takes more time. The one is takes 18 hours to full, and the other is 8 to 10 hours according to the shore power rate. And but to quick charge, you need to add something on capex. And the second part of the infrastructure is the infrastructure from the energy companies. It means that if your port has no electric infrastructure to feed your charging station, this is a problem. Then in near future, most probably, instead of renewing or extending this infrastructure from the power companies, maybe some companies will use some intermediary battery storage facilities as well. I mean, you will fill up the battery storage facility and then use this as a charging station.
Thank you. Ladies and gentlemen, do keep the questions coming. As you know, we will answer as many as we can. Here's one which I believe will bring in Ricky and Chi Wei. I'd like to have some metrics about electric and hybrid systems. Let us consider a standard diesel mechanical vessel. What are the added costs, mass volume for a diesel hybrid vessel, size of battery needed, power as a percentage of installed power, and endurance hours? So quite a detailed question there, but I know you can handle it, gents. Ricky, perhaps you can get us going, and then Chi Wei, we look forward to your views. Do come in, Ricky.
Okay, maybe I will start with that. I believe to be able to answer this question, we need to understand more about the intended operation of the vessel. That would largely affect how we dimension the energy storage. An energy storage that is used mainly to balance the fast transients or the dynamics is very different compared to an energy storage that is intended to be operated for, let's say, entering the harbors or during loitering or during nighttime operation for hotel loads. So in short, it is very difficult to answer in a generic term, as there are many factors that are affecting how we dimension and design the system accordingly.
Chi Wei, your views, please. Do come in.
Yeah, thanks, Ricky, and thanks, Edwin. So one of the key barriers now between the jump from fossil fuels to, say, a full electric is the energy density and the volumetric density between batteries as compared to fossil fuels. So currently, taking the best battery versus, say, marine diesel oil, marine diesel oil's density is almost 30 times as compared to batteries. So for the same amount of energy, it will be heavier, the batteries will be heavier, and also the space will be very heavy for that.
Thank you. Thank you. A safety-orientated question now, obviously an important consideration for all three. I understand, says one of our audience members, that storing non-small quantities of hydrogen on board would not be easy, either very high pressure or very low temperature. How to solve this? Frequent refueling? What about using ammonia or methanol as a way of storing hydrogen? Who would like to come in on that one? Don't be shy.
Maybe if I can start, if it's okay with you, of course.
Yeah, sure.
So from our experience, again, I'm coming back to the intention of the use of the hydrogen and the operational profile. At the moment, hydrogen tanks in a gaseous form at, let's say, 350 bar or 300 bar are quite mature. However, that comes with the trade-off with the energy density, knowing that in gaseous form, the energy density is not as good as it is in the liquid form. Therefore, when an increased energy demand is required, then hydrogen in a liquid form would be required, and the technology for storing that and also for bunkering that is currently under development.
Chi-Wei, please.
Yes, some of the ideas being bandied around now is perhaps the vessel can carry ammonia as fuel, and before the fuel is being injected to the engine, it will be converted to hydrogen. But I also like to echo, for example, Ricky and Ferhat brought up a good point that we also need to look at the entire supply chain, whether the hydrogen is ready to be used as fuel for vessels.
Thank you. Ferhat, you've been mentioned by name. Please do come in with your views.
We have studied and we are continuing to study it. Of course, as a Navtec, a commercial company, so first we have developed these full electric ones, but now we are working on hydrogen cells and so on. But I believe that our research studies are continuing, but I believe that in the future of hydrogen will be a kind of electrolyzing on board. I mean, you have to, how to say, produce hydrogen on board and let's say in the time of consuming, because the storage and that kind of solutions are up to now safety wise not so clear to go on, very difficult problems to solve. Storage is not so how to say comfortable, but I believe that in very near future the producing of hydrogen technologies will be solve this problem, and we will have a combined system on board of the vessel, hydrogen producing some sort of electrolyzing, and hydrogen cells, maybe some backup batteries, I believe.
Thank you very much. Here's a very important question. How do rough sea states impact performance? Perhaps Ferhat, you could get us underway, and then Ricky and Chi-Wei do come in. Come in, Ferhat.
I mean, these, of course, I would like to answer this question on a manner of ZTAC 30, because we have built, finish, and now she is operating. In fact, she is her sailing capability is as well as a normal diesel driven one. I mean, the stability, dynamic stability, and the maneuvering capability and so on, all calculated according to the entire rules, regulations, and so on. So there is no different, how to say, thing about rough sea states impacting to the performance. But of course, you can say that this is, if it takes long, I mean time, but this is not a problem of the rough seas, but a problem of endurance, the energy storage problem. But the other maneuverability and sea keeping and so on, as well as the diesel driving ones, even reaction times are less than diesel ones. There is no reacting time for, let's say, paddle up or paddle down, so it is a bit better even.
Thank you. Perhaps Chi-Wei, then Ricky.
Yeah, just to go back to the point from Ricky, for hybrid and for electric vessels, it is very customized. It has to be designed based on its intended use in its intended mode of operations. Now, rough sea or basically an emergency condition will have to be considered in the design. And there's a trade-off between when we're using batteries. The trade-off will be space versus versus a larger safety margin. So these are all scenarios which the designer and owner has to consider clearly during the design stage of the vessel.
Thank you. Ricky?
Yes, so we believe that with the hybrid configuration of engines plus battery, the performance during rough sea states would actually be improved due to the faster response of discharge from the battery compared to an engine.
Thank you. Gentlemen, you will be aware that when anyone is considering a business case in today's day and age, green factors, environmental factors will loom large. So here's a very pertinent question. If the charging source is not carbon free, then how does that contribute towards green technologies and the green arguments? Who'd like to take a stab at that one? Ferhat, perhaps, and then the other two can come in.
Okay, let me start with a joke.
Okay.
When we start this project, very first times, people were asking us, okay, you're planning, you're promising us to create a emission-free ship, chargeable, but what about the charging power? Charging power is coming through a coal power plant or something like that. We were saying that no, we were designing the charging station, and the charging station is selecting the power from the green power sources, not the coal or some dirty ones. Of course, it was a joke, but at this point, of course, the charging station, if you're connected to the grid, I mean, it means that the national grid, the power company's grid, you have no control about the source of the power. This is totally according to the countries, what is the rate of green energy or so. But for the future, as maybe you may remember from my very short presentation part of LeePort or Z-Port, maybe a localization of the power sources will be on the table. I mean that if you have a port, you can have wind power, solar power, and a combined green renewable energy system together with some battery storage system. And then you can show all the world that 80% of your power source is renewable and green. Or this can be widened to a national, system. But for now, you have no control as designer, as manufacturer, or as an operator of the source of the grid power, of course.
Thank you. Ricky, Chiwei, what do you think?
Yes, so maybe I would follow up with that. I would maybe echo one topic that I brought up during my presentation, in that we should look at the whole vision towards zero emission shipping as a holistic approach. So meaning that not only we look at the technology of the storage, the bunkering infrastructure, bunkering technology, the onboard technology, as well as regulation and class and the supporting infrastructure, including operations and people readiness. So if the source of the electricity is not green, then we are only kind of localizing the green technology on board or on the port itself without looking at the overall picture.
Thank you. Chiwei, please.
Yeah. Thanks, Ricky and Ferhat. Basically, I would echo their point also that this question is one that is beyond the maritime industry. So if you look at the short sea segment, basically a national kind of scope, then the question also falls back onto society. If the green source is more expensive as compared to, say, getting power from the grid from gas or from coal, then would society be willing to pay for the additional cost of obtaining green energy? So the maritime industry is doing all it can to enable grain ships. But this is a more wider question that goes beyond our industry.
Thank you. Ladies and gentlemen, keep your questions coming, because even if we don't get to them, remember, part of the dividend of joining us live is the gentlemen commit to coming back to you in writing within a week of transmission. So do take the opportunity to fire in some questions. Ferhat, I come back to you with a couple of related questions, if you don't mind. The first of which is 2 by 925 kilowatt motors are run from one bank of 1,450 kilowatt battery. And then the related question is on the electrical distribution system. Is it a DC network with zonal AC, and also what fire detection suppression systems are used? So a lot of detail for you to cover. Let's start with the first one, the 2 by 925 kilowatt modes. Do come in, Ferhat.
Thank you. This is a very technical and detailed question. Of course, I am not very well, knowing about all the detailed technology, but DC system we are using. I mean, this is again, this kind of full battery ships must be designed from the very beginning and according to the operational characteristics. For ZTAC 30, particularly, she's a small one, 18.7 meter in length. So we use DC charging system. I mean, AC/DC part is in the charging station on shore. And inside we use a DC distribution system, an induction, and ABBs, of course, HES series we have used because of the, again, lack of space. And the system is here was a combined study. BMA Technologies, which is our solution partner, electric distribution system designer, ABB, and Corvus Energy. We have studied together to create a unique system, because there were no space for big switch panels and so on. And this distribution system is supported by another 230 volts AC bar for consumers and so on, all connected to each other through ABB inverter converters, and the system is now working perfectly.
Thank you. Ricky, ABB's mentioned a couple of times there. I think it's only fair for you to reflect on the themes raised, and then Chi-Wei, if you have any comments on the themes raised, we welcome your views, but do come in, Ricky.
I believe the ABB component that Farhad mentioned are the Hazardous Environment Solutions 880, which is a compact converters that are intended for kind of this IP67 type environment.
Thank you. Chi-Wei, anything to add?
Yeah, so we have seen a resurgence in the interest in a DC electric system with the advent of hybrid and electric vessels, because the DC distribution system has the advantages of it is easier to integrate the batteries. It is easier to integrate, for example, the future power sources like fuel cells and also solar and wind. So in addition to just lithium battery technology, as we go forward, there will be also more improvement and development in the DC distribution technology.
Chi-Wei, staying with you, if we may, here's a question which I feel is in your wheelhouse. How does the use of a hybrid system affect the structure of a ship? If we could change the ship design rules, can we create a better system? Do come in, Chi-Wei.
Yes, because the conventional vessel, the propulsion engine has to be at a certain location in because of its shaft and its connection to the propeller. But with the use of electric propulsion and also hybrid systems, we can move the converters near to the propulsion motors and near to the loads. This frees up a big chunk of the middle part of the vessel, and also allows the vessel to be designed to suit what it is supposed to do. It suit its use, which is more practically. So it allows this rethinking of the design of the arrangement of the vessel, and allows more possibilities.
Thank you. Let us consider the human factor. We focus very much on the technical. Any special skills required for the crew to operate the kind of vessels we're talking about? Ferhat, perhaps you're a logical person to come to first. Others welcome to join afterwards. Ferhat.
Yes, it is a very important question, and thank you. Who asked this question? I cannot see, but first of all, I would like to say that these full electric ones are very simpler than the diesel-driven ones, because you're using just a screen. I mean, a computer screen. It looks like your how to say. Computer or laptop or something like that. But of course, the mentality of electric propulsion, battery-powered electric propulsion ships, is a bit different than diesel-driven ones. So in our projects, we have a training program, 3 stages. The first 2 stages is face-to-face, and the last one is online training through the ship system, to familiarize the crew and the managers to the battery-powered full electric ships. But on the maintenance side, it is easier, very easier than regarding to the diesel-driven ones. But training, it is not a long training for weeks or something like that, but each is 2 days packages, total 1 week or less. A training, I believe, required, and it is necessary, because the operation mentality must be a bit different than a diesel-driven ones.
Thank you. Ricky, Chiwei, do you want to reflect on the question? Ricky, come in, and then Chiwei.
Yes, I do echo Farhad's comment about the different mentality and some understanding about how an electrical system should work compared to the diesel mechanical counterpart, and that would have an impact on the necessary skill sets that we expect from the crew and also from the operators. And I do believe that ABB, for example, we do offer trainings to be able to understand how to operate the systems and to how to maintain the systems. But in general, I do also agree with Farhad that the system is simpler compared to mechanical. For the most part, operations are done through a simplified user interface, and kind of operator manuals will then be also provided for that.
Thank you. Chiwei, please.
Yeah, so I also echo what Ferhat said, that electrical equipment as compared to mechanical equipment is easier to maintain. The only question now is in case of a single failure, or in case of failure of some of the equipment, so the crew on board will have to maybe upskill or reskill to gain a better understanding of this new equipment that they are dealing with, so that they are still able to manage the vessel safely in case of an emergency or a failure.
Thank you, gentlemen. Still plenty to come, including the key conclusions and takeaways of our panelists. And we'll also be previewing a very exciting happening in October. But more immediately, ladies and gentlemen, we have time for another poll question. So it should be appearing on your screen as we speak. What is the main factor influencing your thoughts when it comes to adopting hybrid electric power systems? You've got 4 options in front of you: to realize cost savings in operational expenditure, reduction of emissions, to try out new technology, or is it the case that government incentives are pushing you in this direction? Do vote, ladies and gentlemen. We've had incredible reaction to our poll so far, so let's keep that going. You'll all have a view. The voting is completely anonymous, so please have no concerns on that score. Let's just take another 12 seconds to register your votes. And as before, I will let you know how the options are ranking, but keep going, keep going. So the question, as you can see, is what is the main factor influencing your thoughts on adopting hybrid electric power systems? Is it about cost savings? Is it about emissions? Is it an appetite to try out new technology? Or are you being driven in this direction by government incentives? Well, what I can tell you at this stage of the voting is that in 4th place is to try out new technology. In 3rd place, government incentives. In 2nd place, the second most popular option is to realize cost savings in operational expenditure. And interestingly, given our focus on the green issue earlier on in our Q&A, the leading category as we speak is reduction of emissions. As you know, ladies and gentlemen, we'll report the full findings, including the percentages, in an article after the webinar. Well, ladies and gentlemen, we are now at that point in proceedings where we return to our panelists in the order that they presented and invite them to share their key conclusions and takeaways from today's discussions. That means, Ricky, we hear from you first. Do come in.
Okay, thank you, Edwin. So one of my key takeaway points from the presentation is to realize this vision of zero emission shipping, we need to work together. We need to look at the whole ecosystem in a holistically approach manner. That means from a technology provider, infrastructure, regulations and class, meaning also government bodies, as well as the operators from the people and operation perspective.
Thank you. Chi Wei, we look forward to your views.
Yeah, thanks. So basically, referring to IMO's 2030 and 2050 emission reduction targets, we know that currently certain operational efficiencies and current technology may get us past 2030. However, in order to meet the 2050 targets, it will require an alternative fuel and some method of decarbonization technology that does not exist yet today. However, going forward, hybrid power and electrification will have a big part to play, regardless of the direction the industry will take. So in ABS, we are working with all stakeholders to assist them in their journey to sustainability.
Thank you. Appreciate it. Thank you, Chi Wei. Ferhat, we eagerly look forward to your views, please.
First of all, thank you, Edwin, for this very fruitful webinar, and thank all the attendees over here. Last words, I would like to say that the near future is on shipping is based on electric power systems. Most of the ships will be electric powered, chargeable technologies, and so on, in very soon, rather we expected. So I would like to inform all the operators, ship owners, port facilities, and so on to give a priority on rechargeable technologies, energy storage facilities, and so on. And on this matter, the engineering studies are very important, and there must be so many design or engineering company to study on these rechargeable, storable energy facilities, and so on, for land and for shipping business as well. Thank you again. Back to Edwin.
Thank you very much indeed, Ricky, Chi Wei, and Ferhat, for a very positive and stimulating discussion. And testament to that is the volume and range of questions that you generated. As you know, ladies and gentlemen, we do commit to coming back to you within a week of transmission with written responses. So thank you for your active participation. Ladies and gentlemen, this has been the business case for hybrid and electric technology in Asia, part of Riviera's Maritime Hybrid Electric and Fuel Cells Webinar Week, and brought to you by our premier partner Navtech and sponsored by ABB and ABS. The week continues tomorrow when we look at the all-important topic of how can Asia advance adoption of hybrid electric and fuel cell technologies. So join me at the same time tomorrow. Next week, an entirely new theme week. We'll be looking at maritime cybersecurity, a vital topic in today's day and age. So please be sure to join us next week for those discussions. And in order to ensure that you're never out the loop, bookmark www.rivieramamm.com/webinars. Our program is constantly evolving. We're constantly adding new topics. So please ensure that you are never out of the loop and that is one of your firm favorites. Well, Riviera, for its part, will continue to serve the information that matters most to you. We will do this in a number of formats, through our weekly newsletters, through our magazines, through curated content online that matches your interest, and of course, through relevant events such as this. The important thing for you, ladies and gentlemen, is that you do not miss out. The way in which you ensure that you're permanently in the loop is you register. In order to register, visit our homepage, go to the top right-hand corner, take a minute and a half to input your details. In exchange, you will be kept up to date with news, views, events, and happenings in your part of the business. Speaking of events and happenings, I'm delighted to bring you news of Riviera's upcoming maritime, hybrid and electric events which are taking place in Bergen. We kick off with our Maritime Hydrogen and Fuel Cells Conference on the 26th of October, and this is followed by the two-day event, Maritime Hybrid and Electric Conference, also in Bergen. Many of you will know that we had our inaugural event last year. It was a runaway success. More than 300 people came. We had a complete program, lots of presentations, full networking, and we also factored in a site visit as well. So I urge you to book your tickets now, and I look forward to warmly welcoming you at that time. So more than enough from me, ladies and gentlemen. Safe to say a huge thank you again to Ricky, Chiwei and Ferhat. And of course, a special thank you to our sponsors, Premier Partner Navtech, and our sponsors ABB and ABS. Please, ladies and gentlemen, at the top of your screen, you will see it says feedback and presentations. There's a sharp couple of minutes there for you to click on the red button. Please do so. We value your feedback, and in return, we will send you the presentations and a link to the recording. Wherever you happen to be in the world, please stay safe and stay well. And for now, from me and the panelists, a very good morning, good afternoon, good evening, and until tomorrow, goodbye.